Okay, so this next lesson is going to be broken up into three parts, just like the previous lesson. So in this case, so the objective of this lesson is just to be looking for the surface area of pyramids and cones. In this lesson, part one, we're going to be looking at the surface area of a pyramid, specifically a regular pyramid. So I want to remind you, when we say something is a regular pyramid, that means our base. So if you look at the base of this pyramid right here, let's do this in orange. If we look at this base right here, each of the sides are the same. So the base is a square with sides S by S by S by S. Well, not by, but S by S. Okay? So what we're going to do, just like before, we're going to develop the, uh-oh. I see what I did. I went too far. Part one. Okay. So we're going to, just like before, so that you're not necessarily having to completely memorize this, we're going to kind of develop this. And if you think about what we did before, when we talked about cylinders and we talked about prisms, we unwrapped it. So we're going to do the same thing here. Okay, so we're going to unwrap this again here. So I'm going to kind of put this together. So I'm unwrapping this. And this won't be perfect. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's go to 12. Let's backtrack. So 2, 4, 6, 8, 10, 12. The only reason I'm doing this is to make it look a little bit, I want it to look a little better as we go through. So in this case, what this is going to look like, when we unwrap this, it's going to kind of do this. So you kind of imagine this thing has four sides. It has four triangles, isosceles triangles. So let's see if I can draw four of these correctly. That is a big if. I'm trying to make them all look like they are congruent. I don't know if I'm going to succeed or not. I messed up on that last one, didn't I? I did. Let's see. So that just goes 1.5. So this goes 1.5. And the last one's going to go like this. Okay. So these are, if I unwrap it, I think you'd agree. I haven't dealt with the base yet, so that's kind of the lateral sides, and then we have this base, and I'll just kind of draw this down here. We'll deal with it at the end. Actually, the base would look something, if we were doing it perspective-wise, it might look something like this. Okay? But we're not going to worry about the base right now because I think you'd agree the area of the base is easy peasy, right? It's just a square. It's the lateral sides that we have to come up with the area for. So we're going to go find the area of these lateral sides. And the way we're going to do this is we're going to see, right, that I could make a rectangle from this. I think you'd agree, right? If I were to kind of extend this, I'd make a rectangle. So what we want to do is, I missed a little bit. This side should go out to there. So we want to figure out if this is the part that we want to find, right? This shaded portion. That's my surface area of the pyramid. Excuse me, I'm going to cough in just a second. What is that area? How much of what percentage of the rectangle is it? What fraction of it? So let's kind of look here. I think you'd agree, it kind of looks like it's half of it. Let's see. There are four triangles. When we look at the shaded part, there's four equal triangles. Well, let's see if that's true. Here, there are three equal triangles. Their bases are, whose bases and the heights are the same as the other one. So that's true. So that works. But also, right, these two pieces make a fourth triangle. So in other words, I think you'd agree that if this triangle, right, if this rectangle has sides S by S plus S plus S, if that's right, if that's the bottom, and then the height, right, the height, if you notice, is just this height right here, right? It is that red line, and that's given to be L, right? So we can, in other words, if we wanted to find the area of that lateral area, I would say it's 4s times L. But of course, that 4s, just like we saw the other day, that 4s also happens to represent the perimeter of the base. Okay, so our formula, let's start with the lateral area. So the lateral surface area, oops, I was going to spell surface wrong. The lateral surface area would be, well, wouldn't it be half the rectangle? Where, again, I want to remind you, this 4s right here is the same thing as the perimeter of our original pyramid. So in other words, it's going to be 1/2 the perimeter times the height, or times the slant height, L. Again, L is representing the slant height. And again, that 1/2 is coming by because we only need half the rectangle, not the full rectangle. And of course, the base, as we said before, the base is just equal to s squared. So the full surface area of our pyramid is 1/2 the perimeter of the base times the slant height plus the base, the area of the base squared. Okay? Or a side squared. I don't know why I'm saying the area of the base squared. That didn't really make much sense. The units are squared, but it would be a side squared, or the base. Okay, the area. So we'll say the area of the base. So actually, if you don't mind, I'm going to remove that s squared, and I'm just going to call it the area of the base to give it a more general, so it looks kind of like what we did the other day. Okay, so that is the area. That is the surface area of a pyramid. So one more time, the surface area of a pyramid is half the area of our rectangle, right? So if we look at this, it is half the area of that rectangle. And again, that rectangle, I don't know why I did it that way. So half the area of our rectangle. And the area of that rectangle is the perimeter times the length. So 1/2 the perimeter times the length plus, we have to find the area of the base, right? This piece right here, which is just a square. So in this case, it'd be s squared. Okay? So this is our general form for finding the surface area of a pyramid. So let's go, we're going to look at two different examples. So example number 1. In this example, they gave us the one side of our base, and this is again a regular pyramid, so one side is perfect. And they also gave us the lateral, the length of our lateral. Okay. So in this case, just really quickly, when we talk about the lateral height, what we mean, just to be clear, is it's the line that goes along the edge of the triangle. So if I were to kind of pull out one of my sides of this triangle, and you guys have probably already figured this out already, but I just want to make sure you're okay with it. So the lateral height, right? So if you imagine this pyramid, it starts from the vertex of that, and it travels along the side. Okay, it travels along the side, and then it bisects it. It'll be perpendicular. It'll be perpendicular to that side. Okay, because it's the perpendicular bisector. But again, just kind of imagine it's going along that line, that lateral line is going along the surface. So it's not the height, right? It's not the height of the pyramid. It's called the lateral height or the slant height because that line travels along a slant. Anyway, moving right along. Let's go find the area. Let's go find the surface area of this. So in order to find the surface area, what do we need to know? Well, let's start with the lateral area. Okay, so the lateral area, or the lateral surface area, is going to be equal to 1/2 the perimeter times the slant height, right? So that's going to be equal to 1/2 the perimeter, right? Well, one side is 5, so 5 plus 5 plus 5, or 5 times 4 is 20. And then the slant height is 12. So we get 1/2 times 20 plus 12. which is going to be why did I say, oh, well, I guess that's fine. It doesn't matter. I think I got my things a little bit mixed up. I don't think it's supposed to be a 12, but anyway, that's going to be 10 times 12 or 120. And again, this is a surface area, so our units are going to be inches squared. Okay? So one more time, it's 1/2 the perimeter, right, which is 5 plus 5 plus 5 plus 5, times that slant height, which is 12. That gives us the lateral area, but we still have to find the area of the base. And again, the base is just a square. So the base is 25. So the total surface area, so I'm just going to say the surface area equals 120 plus 25. So that's 145 inches squared. Again, squared units. Okay? Let's look at one more example. One more example that might not be so obvious. Now, this one's going to be a little bit hard to see, so let me just kind of explain what's going on here. Hopefully this is going to make sense. So, in this case, again, they gave us the base. They told us that the base, right, is a square. It's against a regular. It's given to be a regular. The base is a regular square, or a regular figure. In this case, a fourth square. But this triangle that they're giving us, in this case, what it does is it starts from the vertex of our triangle, but it drops right down to the center. Okay, so it goes down vertically. So it's actually the height of the triangle. So if you were to measure the height of the triangle, like if you were to put this pyramid on your desk, it would actually be the height of the triangle. But that height, it actually is the exact center of our square. And then we draw a line, right? If you notice, we draw a line from there to one of the sides, okay? And again, it will bisect that side because that original point was in the middle of the square. So this one, if we draw it perpendicular, will bisect this side. So what ends up happening, right? If you notice, I will kind of label as we go through. Not that we need all these values, but I think I'm forgetting a number here. Let me just double check. I thought they gave me another number, so they did. So they did tell us that the height in this case is 12, I think it's in inches. Let's say everything's in inches. Okay? So again, this 12 represents the height of the pyramid. It's not the lateral height. The lateral height, we don't know. That lateral height is this, right? It goes along the side of our pyramid, but we don't know that. We have to figure it out. So let's see what we can do, because that's going to be the hard part here. We're going to have to figure out that lateral height. So let's see. Notice that this triangle right here is a right triangle, right? And we already know one of the sides. One of the sides is 12. And I think you'd agree with me, we actually know the length of this too, right? If this point right here is in the middle of the triangle, then I think you'd agree this has to be 5 inches. Okay? So we should, because of Pythagoras' theorem, we can then go through and solve for this lateral side. Okay? So we can say 5 squared plus 12 squared equals our lateral side squared. When you solve for that, you're going to get L equals 13. Okay? Now we have every bit of information that we need. I'm going to shrink out here. So let's go put all that information together. So let's find the surface area. Or the lateral area. So the lateral area, well, it equals 1/2 the perimeter. I think you'd agree. Since the one side is 10, that's 1/2 of 40, times the length of our lateral side, which is 13. So in this case, we get 260 inches squared. Then let's go find the base. And the base in this case, again, it's just a square. So it's 10 by 10, which is 100 squared. So our total, our surface area, is 260 plus 100. I shouldn't have put 100 squared, excuse me. That's 100 inches squared. So it's 260 inches squared plus 100 inches squared, or 360 inches squared. And that is part one of this lesson.